Hello, everyone, and welcome. Thank you all so much for joining us today for this live stream event. My name is Alexia, and I am the Program Manager of the Microsoft Reactor Toronto. I will be sharing session resources with you in the chat, but before we begin, I'd like to quickly review two items, our Code of Conduct and event guidelines. First, please take a moment to review our Code of Conduct. Microsoft Reactor seeks to provide a respectful environment for both our audience and presenters. We encourage engagement in the chat, but please be mindful of your commentary, remain professional and on topic. And secondly, our event guidelines. This session is being recorded and will be available on demand through the Microsoft Reactor YouTube channel in about 24 to 48 hours. I will share the link in the chat for our on-demand content. And if you have not been on the live stream through YouTube before, please note that you must create an account on YouTube in order to have access and interact in the chat. You can set that up now, and if you're unable to use the chat but have questions, please feel free to reach out to us through social media or on our website. Which brings us to today's session. I'm going to bring in our speaker here for today. Hello, hello.
Hello, Alexia. How are you?
Great. How are you doing? Welcome back on the
I'm doing
Reactor.
pretty good, fantastic, pretty
Amazing.
excited.
Yeah, we're very excited to have you on for today. So without further ado, take it away.
Sure. Thank you, Alexia. Hello, everybody. Good morning, good evening, good afternoon, depending upon where you are joining this session. Welcome to my session, Beyond Chatbot Building Intelligent Multi-Agent Systems with Azure AI. So before we start, let me ask you a question that how many of you have worked with multi-agent systems before this? So whether you are just getting started or already working with agents, today's session will definitely help you to understand how to efficiently manage, persist, and restore the agents, how to build it from the scratch, and how to make it a scalable program. So let's get started. Before I start, here is a brief about myself. My name is Rajneesh Kaushik. I'm based out of Toronto. I'm a Microsoft MVP, Databricks MVP, and Databricks champion. I'm a TUGAF certified enterprise architect with over 22 years of industry experience working with Fortune 500 companies. Here is my website and YouTube channel along with MVP profile and LinkedIn if you want to connect. So let's get started. Here is a agenda for today's session. First, we are going to understand for introduction and motivation of AI agents, why definitely we need AI agents. What is a typical AI agent looks like? What are the basic concepts of AI agent and how the AI agent works, along with the different kind of capabilities the AI agents provides. Then we will dwell deeper into the concept of code executors in AutoGen, how AI agent can help you to put human in the loop concept, what are the teams and termination flow in AutoGen, how do we manage the states in the AutoGen, and how do we initiate the chat with the selector group chat and swarm in the AutoGen. Then we will understand Magentic-One custom agents and other concepts like serialization concepts. And finally, we will definitely jump to a demo where we are going to understand all these concepts in the real life example, where we are going to implement a application for the support customer support workflow application, where we are going to use all these concepts. So let's get started. So first and foremost, what is an AI agent? For those of you who don't know AI agent, this is a very brief, is going to give you a very brief idea about it. So AI agent is something like a intelligent system who is capable of receiving an input and processing the knowledge based on the LLM models. So AI agent serves by leveraging the LLM models and then provide the answers. For example, if suppose I'm asking a question like how old is the universe? And in that case, the LLM knowledge base can process the question and return the answers. So instead of you interacting with multiple systems, actually your AI agent is doing this, for you. So it is something like your PA or private secretary who is asking you what you need to do, and then it is performing the tasks for you, right? So that is called the agent, but it is based on AI, which means it uses the LLM behind the scene for performing all your queries. So that is the AI agent. So now you might be thinking, what are the different concepts used in the AI agents, right? Because AI agent, it actually operates, with the help of interacting with the users, depending upon what kind of flow it requires. It will gather the inputs. It may gather the input from the users or from the external systems. It can respond basically based on the knowledge base which it has already accumulated, or it can call the external tools outside the agent, right? And that, given, it can give you the options to search the web query, search the database, or execute a code based on your query. So it can dynamically create a code, it can execute that code, and then perform the specific set of tasks. Like, for example, if I ask you a question that find the latest stock price for Microsoft, and then LLM does not have the data, right? And as you know that retrieval augmented generation RAG, right? We can definitely call the external system to get the work done, and that is what the AI agent does. AI agent calls the external API, like for example, in this case, it can call stock market API, and then in that it can retrieve the latest stock information and then display this information to a user. So this is how the AI agent fundamentally works, right? So now you have gained the fundamental knowledge of how the AI agent works and what are the basic concepts. Now dwell deeper about what else this AI agent can do it for you, right? Like for example, AI agent can interact with users, right? It can receive the queries, it can process those queries dynamically, provide the responses to the users. It can, search the external data. For example, if you want to search the internet and find your answers, or you want to search a database, different databases, and then those databases contains different set of information, or it can call a REST API call externally, and that REST API call returns some response, and based on that response, it can parse that response and then give you the proper answer. It can also, execute certain commands. For example, it can run the command in your system to find out certain files, or it can do the command for fetching certain set of reports, right, which is already there. And not just that, it can also adapt and learn, right? When I say adapt and learn means, suppose in the first step, user AI agent could not finish the task properly, and then based on your response, how it performed, it can improve its performance through interaction and feedback. That means inspect and adapt. So if you are not happy with the response, then it will understand that user is not happy with the response. It will change the response, okay, based on the feedback, and then again execute that code when you do the same, when you ask the same question again. So these are the some of the capabilities which it brings to the table, right? For example, you can also search a CSV file. You can also call a externally created tool, so like, for these are the real world applications of AI agent nowadays, right? And it's becoming very, very popular. For example, a personal assistant like Siri or Alexa, right? That performs your jobs. It can interact very well with the user. It can perform all the actions for you. For the business world, we can use AI agents for generate the reports. We can analyze the data which is there in the report. And based on that data, we can execute the workflows, right? It can also it is being widely used for the customer support capabilities. For example, nowadays when you call any customer support, toll free number, that time chatbot handles all the queries by pulling the real time data which is coming in the databases, and then respond to you. And most of the time you might have seen that your customer support agent, you don't have to connect with the real live agent. Most of the solutions are already provided by the agents, AI agent, right? And some point of time, if you feel that the AI agent is not able to provide the answers, then the concept of human in the loop comes, where the human it transfers the control to the human, and then now human take over the task and then start working on it. So these are the very critical capabilities of a typical AI agent. Now, because as you know, this session is for AutoGen, right? And what is AutoGen and why it is creating so much waves in the industry? Because this is one of the very advanced multi-gen framework that helps you to enable your AI agents so that these agents can collaborate among each other. They can collaborate with the user. It can not just collaborate, it can also do the reasoning on the top of it and automate very, very complex tasks, right? Which requires a number of steps. And it does it with the help of a LLM model like OpenAI or Mistral, or there are different models. And then it also has a capability to connect to the external tools. That is where the it becomes a very, very efficient and autonomous. This AutoGen framework is developed by Microsoft, right? What are the different key features of the AutoGen? It has a capability to do enable multiple AI agents to work together, right? So it is something like you are working with army of AI agents, and each of these AI agents are capable to do very specialized tasks for you. For example, if you are trying to book your tickets, or you have a travel plan for vacation plan, then it will go to the different agents. It can go to the flight booking agent. It can book your flight. It can find out the local restaurant for you. It can find out how do we do the taxi booking. All those capabilities are already inbuilt into it, and those agents work together as a team, and then they solve the complex problem step by step approach. So this is the capability. Now there are, when we say multi-agent collaboration capability, it means that these agents can chat, interact with internally as well as externally. They have a very specific tools integration for external system connection, or with the help of API, or you can build your own tool and then use that tool to which AI agent can use, and then execute your task. It also has a unique capability for adaptive workflow automation. That means it is not a static workflow which you are going through. Based on the different conditions which is coming, it can change the workflow, and those workflow change happens based on how the user is behaving, what kind of problems it is facing, and what kind of conditions is coming dynamically. And based on those adaptation, it automatically adapts itself and then changes its flow of execution. It also has a very unique capability to use memory, so that when you use a memory in the interaction, you don't have to again ask the same question, because now you remember what user has asked in the last session. It also captures the history of the conversation, so that AI agent is becoming so smart that it don't have to ask multiple same kind of questions again and again. And then it also understands, take the feedback from the user, and then improve the response as and when it goes to the next step. Now you might be thinking, why do we use AutoGen, right? Because at the end of the day, we all want to be very productive, and when we want to be very productive, we want to make sure that we get rid of the repetitive tasks. We can enhance the collaboration. We can use the flexible options like AutoGen for building all our applications. So some of the key use cases are like AI Copilot for coding assistance, right? And let me give you a very real-time example that if you are working, developing a code, and generally what happens when you develop a code, one developer develops it, then it goes to QA. QA tries to test it. After testing is done, then again the bugs are raised, and then again developer works on that bug, and this is a typical flow. And once everything is done, then finally deployed to the production environment. So now all these capabilities can be built with the help of AI agent, so that you don't have to develop the code. The AI agent develop the code, and at some point of time you feel that this is not making sense. The code is not developed as per the scenario you are expecting. Then it can change that code, right? That is called human in the loop. The same kind of capabilities also there in research and document summarization, where it is used for researching the documents, and going in the internet, finding out the doing some research on the topic, and then summarize the document based on the research it completed. It can also do the data analytics and reporting capability, where you can parse through so much of data in the internet, or it is there in the different files, and then parse it and then generate a sensible report which you are looking for. And good part is that, as you know, that the frameworks like LangChain, right, it provides different kind of multi-step task execution capability along with the reasoning. So it becomes a very, very powerful concept now, right? And Microsoft has done so much investment in this AutoGen, and it is a fundamental tenet based on the multi-agent system, right? So let's now dwell deeper into it and understand how code executors in AutoGen works. Because at the end of the day, all these AutoGen capabilities which we just discussed is actually trying to execute a code somewhere, and that code is either getting executed in the locally where the system is running, or it can run its code outside the system in a Docker container. And you might be thinking, why I need to run this code in the outside the local machine? Because at some point of time you want to make sure that you want to make this code run in a very secure environment, right? Because AI can run some code with some security privileges you may not be interested to run in a secure environment. So it is always a good practice to use Docker container to run this code in an isolated container, and that way all the code execution happens in the Docker, and then the results are reported back to the agent. So this is one of the two options for the execution method, right? Now let's change the gear and then understand what is the concept called human in the loop. Okay, and why humans are required in the system for AutoGen, right? So when we use any of the AutoGen or AI agents, right, it is very, very important that users are kept in the loop and they keep providing the response to the users or the AI agent, and then the AI agent understand the response and change its direction, right? um, this is very, very critical. For example, if suppose you are writing, AI agent is doing some analytics, right? At that at time of analytics, it is providing some results in a report, and that report is not what user is expecting. So user may provide a feedback to the agent that this is not what I'm looking for. Please change this parameter, or please change this graph, all right, or please change this comparison. uh, so that is where the real time feedback is very, very important. So there could be multiple way of providing the feedback. One way is a real time feedback, where AI agent executes some task, and then based on that execution, the user is providing the answer, like whether this task is correctly executed. If user provides that kind of real time feedback, then it is called real time feedback. There could be another scenario, right, where user can provide a feedback after the execution, which is called post run feedback, where user input is provided in the next execution cycle. For example, you execute all the tasks, and then after that, at the end, it is asking you the feedback, right? And then that is where the user provides the uh, response, and based on that, it again re-execute the whole steps, right? So this is another example of post run feedback, right? For this is there is one example to both of these, right? One of the example could be that if you are writing a blog, and I don't want that once you completely write the blog start to end, then only I should be providing you the feedback. I want to provide the feedback there and then after every paragraph, and that is where the collaborative writing happens, and that helps you to improve the writing approach, improve the way you are writing it, and that is where the AI human collaboration writing works, right? And that is how the user approves the response, and then AI agent take the improvement which is expected by the user and then executes it. Similarly, if you have a moderation and refinement of AI, so you can do moderation in the middle or you can change it. For example, in a teacher agent, and whenever a homework is given to the student, right, which is a live human being, and then whenever the student submit the answer to the question, the agent provides him the answer, what is wrong, and then the whole human interaction keep on happening unless you complete the entire assignment. So this is another example where human in the loop is very, very important concept. Okay, so now let's understand the next step, and that is where we are going to understand what is teams in AutoGen. And these are fundamental concepts, right? And if you have good understanding on the fundamental concepts, you can definitely learn any technology very easily. So we are touching upon the fundamental concepts. So let's understand what is teams. Okay, so teams is nothing but a group of AI agent working together to achieve a common goal. Why we require a team? Team is required for designing a complex task which require a different set of expertise from the people. Okay. For example, for a travel booking or vacation planning application, you need a specialized expert who knows the flight booking, and who can find out the cheapest flight. Another agent, which is a vacation planner, the vacation planner can find out how much, if you are going in a specific location, how do you plan your vacation, where will you stay, how will you plan your vacation, what are the special points where you can visit, right? So those are the specialized expertise which is required by the vacation planner, right? Then there could be another agent which is used for booking your travel plans locally, like for example booking your taxi, right? There could be another agent which will help you to change your forex currency. So there are different expertise, one for each, and that is where the complex task could be performed with the multiple agents. And good part is that these agents works together in a very structured way. You think it as if you are working with your own team, and that team, they are working with each other, and interacting with each other, getting the ideas, executing those ideas, and making it happen. Now, when should you use a team? Mostly in the AutoGen, you will definitely use a team, because you are going to develop multiple agents, right? So the best practice is that you start with a single agent, which is a very simple task, which does not require any team. But then once you think that your tasks, there are multiple tasks in it, you can use multiple agents, and those agents have their own expertise. They can require diverse expertise and different kind of collaboration with each other, and they are optimized agent, they know their stuff very well. right? And those agents now work in a single team and interact with each other. So this is the concept of team in AutoGen. With this, now we will move to the concept of termination of flow in AutoGen. Okay, so what is termination of flow? Whenever whenever your agent runs, okay, at some point of time, you need to stop that agent, okay, and otherwise, if you don't stop this agent, it's an AI agent, right? It will keep on running, and it will keep on running for a couple of days, right? And you don't want it to run for a couple of days. You only want it to run till the time your objective is achieved, okay? And that is where we need to put a termination flow in AutoGen. Termination flow helps you to control when an agent or a team should stop the execution of the workflow, right? There could be different stopping conditions. Like for example, you can say that if message limits, there are 10 message you can communicate in this chat, right? If there are n number of tokens which is already consumed, we can stop the communication. Or if there is a specific event, for example, a user clicks or user types that I'm satisfied with this flow, and then in that event the termination can happen. Another specific event could be that if suppose there is a specific condition in a database table, and the agent is trying to search that condition in the table, and if that condition is met, then it will terminate the flow. That condition could be a success condition, or it could be a failure condition, or it could be a condition which will trigger another set of workflow, right? So this is a very, very important concept, termination concept, which is very essential for multi-agent workflow to maintain the efficiency and control at the same time. Okay. So now, after understanding termination of flow in AutoGen, let's understand what are the different conditions we need to know. Okay. So there are these 9 conditions, right? And let me explain you what are these conditions one by one. Max message termination means that you stop the flow after specific number of messages are read. You stop when a specific word like terminate comes in, and the user types the word terminate, and in that case you stop the overall flow. Token usage limitation is when you stop the flow when a predefined token usage limit is reached. Okay, so this is where you need to put that condition. Timeout termination, where after running the flow, for example, for 5 minutes, you want to make sure that it is stopped. Okay. Handoff termination. Handoff termination is where, suppose now your agent is has done its job, right? For example, in a customer support, now agent has done all the activities, and now it want to stop the it want to hand it over to the live agent. So once it hands it over to the live agent, that time it will stop, and now the live agent will execute its work, and then stop it on its own. So but it will not keep on waiting for the live agent to finish it. It will stop it because it already handed it over to the live agent. Same way, if you have a source match destinations, right? For example, if suppose one agent respond, and that response is what you are expecting, and once that response comes, then you can say that, okay, now the source match termination condition is met. This example could be, suppose you are working on um, a, a book writing, for example, right? In a book writing, one of the agent, which is a writer agent, and then there is a critic agent. So now if writer agent writes some paragraph and critic agent approves it, that means the approval is done, and that is where the particular critic agent is approving it, and then it is actually stopping the execution, and now the writer will stop it. There could be another condition called external termination. For example, in a UI stop, there is a UI given, and in that UI, you are stopping, you're clicking a stop button, and at that point of time, it will stop. Similarly, if you have a another method which is called stop message termination. When a stop message is received, that means it will stop the whole communication. And the last but not least, it is called stop call termination. Stop call termination is when your function call execution matches a given name. That means if suppose you execute a function and that function call execution happens, and that it gives you some specific set of responses which you are matching, and then based on that messaging you are actually terminating the agent. So these are the different termination flows. Okay, so now let's switch the gear. How do I manage the state in AutoGen? Right, and this is very, very critical. And what is the state? State means suppose a agent asks a question, "What's your name?" And then user provides its name. Okay, my name is John. Now, after some time, when the conversation is keep on happening, right, and then after that the session changes, and now it goes to another user and asks another question, and then another user asks this question that from where you got this information. Then the agent need to know that it spoke to John, and John provided this information, and it need to preserve that state, right? So that if it does not preserve that state, it will keep asking the same question multiple times. So it is very, very important that managing the state, is critical for in AI agents, because it can restore the process after some time. For example, if you are working, with the agent, and after some time you got a phone call. After the phone call, you again started working with the agent, and now agent forget your name and all the context what you are talking about, right? And you might have seen it, right? Whenever you call the the customer care agent understand the last time you call it for this particular purpose, and that is where it start the communication, instead of it allows you to repeat the whole thing again and again. So it understands the whole context. That is where the managed state comes handy. Then there is another concept called restoring the state, and this helps, the whole process helps you to enhance the multi-agent workflow with a persistent state. Now you might be thinking, how do I persist this state? Right, there are three options. You can save and load the agent state, that means the agent which is working, or you can save and load the team state, right, the whole state of the team, or you can persist the state in a file or a database, so that when the user comes back again, you can query that file or database and restore or retrieve the information from the file or database, and then start communicating from where you left last time. So this is very, very critical. How do we manage the state? Now, what is the memory management? And why the memory management is a critical concept. Memory management allows all the agent to remember the past interactions and improve the responses. Because if you don't, understand what you have spoken to the agent last time, then you may have to repeat it again, right? So that is where the multi-turn conversation, which happens with the AI agents, they store this and retrieve it for the relevant context. And in AI agent, we can extend it by storing and retrieving the useful facts. Okay, and that this is generally used in a RAG systems for retrieval augmented generation patterns. So these are the different methods which could be used in the libraries. Like one is they add new entry into the memory store, or query the entry, or update the context. Whenever the context changes, you can update the context. You can clear all the context from that, or you can close by cleaning up the memory store. So these are the couple of methods which is used. And memory management is also very important, because you have spoken to a agent in length, and now when agent communicates back to you again after 10 minutes or 1 hour or next day, and if it does not know the memory, or what you have spoken to it, then you have to again again repeat yourself, and nobody likes that. So that is where the memory management comes. Now, real world example, as I already provided you the real world example, that AI assistant that remember your preferences, right? For example, last time when you spoken to it, it understand, what kind of coffee you have ordered, right? What kind of preferences you have, or you want a, specific, your specific way or specific language need to be spoken to you, right? And the agent is now communicating to a person who belongs to Mexico, and now agent understand that this person belongs to Mexico, and it has the memory management capability. Now it started communicating to that agent in a different language, right, instead of communicating it in the English language. So these are some example of memory management. Now, there is another very critical concept called selector group chat. Okay, selector group chat is a concept where you enable dynamic agent collaborations. Okay, so what is dynamic agent collaboration? So suppose if you are sitting in a conference room, and in that conference room there are multiple people sitting with you, right? And if everybody started speaking at the same time, you won't be able to understand who is speaking what. The exactly same problem happens when you have multiple agents working in a team. So selector agent or selector group chat is a feature where the AI agent under select the next speaker depending upon the context, and then enable that coordination between the multiple agents. For example, now user ask a question, and now the first question is that, shall I plan my vacation to France? And then the first agent which it will ask the question is vacation planner. Then the user asks, what is your flight details? Then it will go back and then ask the flight agent, not the vacation planner. So these are the specific features which is very important. And why these are important? Because the speaker selection, and then it helps you to configure the roles and descriptions. It prevent the consecutive turn by the same speaker. That means if one speaker keep on speaking and then you are taking instruction from it, it does not make sense in a practical scenario. And it also supports custom selection prompts. That means if suppose you are a asking a specific question related to vacation planning, or specific question related to the flight booking, then based on that prompt it will select that particular agent. How this whole thing works: team analyzes the conversation context to determine the next speaker, and then that particular select is agent is selected, and then it respond, and then this response is broadcasted to the entire team of AI agents. And then once the termination condition, unless the termination condition is not met, in that case the conversation is keep on happening. And then if the termination condition is achieved, then that time the completion the whole chatbot is stopped communicating now, and stop asking the question to the different agent. So this is how the whole selector group chat works. Now we have another concept called swarm in the AutoGen. So what is swarm? Swarm is a concept where multiple agents collaborate with each other in an autonomous way and delegate their task based on the different capability, right? And some of the concepts called task handoff based on the specialization. And for example, if I'm handing off this task to the travel booking agent, right? And then travel booking agent, once it is done, then hand it over to other agent, flight booking agent. So this is concept called decentralizing the task delegation. In this concept, you all these agents share the messages for the collective decision making, so that they can collectively make the decision. and they can also parallelly execute this whole workflow. How this whole thing works? First, agent analyzes the task, determine whether the to complete or delegate this task. If suppose I cannot complete this task, I will delegate it to somebody else, right? And then if I have to delegate to somebody else, it will hand it over with the hand of message. And then once the uh, task is done by the the other agent, right? If that agent require another assistant because that agent is not specialized to complete the end-to-end task, then it will again hand it over to the hand off to the another agent, ask the question, and then once that agent gives you the answer, the it execute the its part, and then it execute and give it hand it over to the another agent. So it is something like a chaining, okay, and this chaining keep on happening unless you the termination condition is met. So this is called swarm. Then we have another concept called Magentic-One. Magentic-One is a concept where uh, is a special or generalized agent which can design, which is designed to solve different kind of problems together. For example, it can solve open-ended web or file-based problem in a one shot. So one example could be if you tell the agent to execute some task, it will go ahead and then do the task planning. It will go to the web surfing. It will do the it will write a coding. It will execute the code. It will go to the terminal, and it will also have a seamless integration with the different workflow. So this one is very critical because it can be used for your day-to-day task, where it has a capability to do interaction within your machine, and then all the capability of web surfing and file opening and other capabilities. So it has these capabilities like orchestrator, web surfer, file surfer, coder, and computer terminal. These are the different kind of tasks it can perform. And generally, when you use Magentic-One architecture, make sure that you use Docker container or for sandbox AI action, because it could be sometimes generating a code which could be potentially dangerous. So if it executes it in the Docker, it is always good. You also make sure that you run a virtual environment so that in the virtual environment you have unintended access. You make sure you are monitoring the log for unexpected behavior it is executing, and then it also require a human oversight, so that it is not doing what you don't want it to do. Okay. Then the concept of custom agent in AutoGen. So custom agents are agents which there are specific set of agents generally available which will fulfill all your needs. But in case if there are agents which you want to create your own agents and the agents are not available for you to work on, then you can create your own custom agents. You can inherit the agent chart and then add a specific set of capability in the agents and build your own custom agent which is not available as of now. So that provides you a added capability to create your own agent based on your own needs. And these agents have a different behavior. They are very modular and reusable. They have extensibility support. So these are the specific. And then last part of the slide is serializing components in AutoGen. So why serialization is important? Because serialization enables the AutoGen to save this whole component in a JSON structure, right, in a declarative specification, and then you can provide this component to your colleagues, or you can run this component again with the help of AutoGen Studio. If you have this JSON file with you, you can upload that JSON file and then use it, or you can give this JSON file to your colleague, which can start using this whole component by loading this JSON file or serialize in output of the AutoGen and then start using it. So these are, and then this also provides a capability where you can change this JSON structure based on your needs. So this is very critical. This is used for debugging and visualization, reusability, portability, right? So these are the critical this one. Now let's jump to the demo. Okay. And I'm going to show you a demo where I'm going to provide you capability which we have just discussed. Um, so this demo is actually, we have mimic a demo where there are multiple agents we have created, right? And you see how easy it is to develop the whole AutoGen framework, right? So now if you see here, one second, here it is. Okay. So in this AutoGen agent, what we have done, we have um, created a environment here. In that environment, we have created an OpenAI endpoint, OpenAI key, OpenAI deployment, and then API version, right? So the first step is to set up your OpenAI environment, and then how this whole agent works. It uses the different libraries which is provided by the AutoGen, like AutoGen extension model, OpenAI agent chat. This is an agent chat library, right? We are exporting it. Then we are loading the environment variable, like OpenAI endpoint keys and other aspects of it, like version, so that we can call the LLM model. Then here we are going to create a AZ model client. Okay, this AZ model client is nothing but it is connecting to the OpenAI, and this is LLM model. Now we are started creating a agent, and you see how easy it is to create a agent in the in the agent AutoGen. So first is your inquiry agent. Okay, and here we are actually mimicking the agent which can handle the customer inquiries and then classifies them based on the inquiry. Okay, and it is using the same model which we have developed here. So good part is that you can use different models. If you want to use Mistral model or any other model, you can just put that model here. For the sake of simplicity, I'm using a fundamental model, which is our OpenAI model. Now, in the inquiry agent, what I have done, it this agent actually handle all the customer inquiries. So this is a front-facing agent, right? And it can handle the inquiry based on the different categories. For example, if it is a product query, then it will forward it to response agent. It has a technical issue, it will hand it over to troubleshooting agent. If it is a request for documentation, it will have it will hand it over to knowledge base agent. So there are different agents we are going to create. For example, this is a response agent, and this response agent, what does it do? It generate the response for a classified customer inquiries. Okay, and similarly, if we have a knowledge base agent, it searches the company's knowledge base for the solutions. Same way, if you have a troubleshooting agent, it can guide the customer through the troubleshooting steps, and then provide the response so that customer can troubleshoot its problem, right? Same way, if we have a feedback agent, it collect the feedback from the customer and analyze the feedback, whether the feedback is positive or negative, and in that case it can also call external parties. Same way, you have an escalation agent. The escalation agent identify the case which is not fixed, and then it can escalate to the user or a live agent, and then live agent can start working on it. And these, after the agents are deployed, like developed here, we can create a user proxy agent. Okay, what is user proxy agent? User proxy agent is a specific kind of agent which can actually use your LLM model, where it can mimic as a user on behalf of user, right? And it call a function as well, and this function is actually respond to the user request, right? Here it is called proceed, so it is going to say proceed, right? And when I'm going to come here, it will see, you see this is how it is saying proceed to the next step. Then after that, there is a another. So these are the different agents, user proxy agent. Now this is, there is a condition to terminate. What is the condition to terminate? If you say approve, then in the text, if it find anywhere the name is approved, then it is good, or the maximum message size becomes 50, and those conditions are met, or any of that is met, then it is going to terminate it. Then we are creating a team, and in this team we are going to create a selector group chat where we have a different participants, and these different participants are nothing but the agents which we have just created, like user proxy agent, troubleshooting agent, feedback agent. And now after that we have put in a terminating condition which we have defined here. And then this is the initial query which will be run by the customer. What is the initial query? That my internet is not working and I have already tried rebooting the router. Now please tell me, how do I troubleshoot this whole problem? Then after this, we started the this message, text message, and in that text message, we started the initial query of the user. And this is just a stream where we are running the team. Okay, in that, so what we are doing, we are fetching the value of the user and then running it into the team. And then after that, we started the execution of this whole. So let's see how the whole execution happens. Okay, so this is overall execution which is happening, and I will show you how the whole step-by-step approach works. So first and foremost, user comes and say my internet is not working and I have already tried rebooting the router. Then inquiry agent say this is a technical issue, because the inquiry agent's job is to find out what kind of issue it is, and then it forwarding the inquiry to the troubleshooting agent. Now after it forwarded to the troubleshooting agent understood, and then it says that let's work together to get your internet connection back online, and I want you to follow these steps. So after, it gives you step by step instruction. It saying that run a quick connection test, look at computer indicator, restart the device, check your ISP status, and then user says that yes, proceed. Okay, so now after proceed, again troubleshooting agent say great, let's go through the troubleshooting steps systematically and I will guide you step by step and figure this out together. So again after that, it says that now confirm if problem is solved or not, and it say proceed. So now troubleshooting agent is saying yes, all right, since you did not specify all devices are affected, because I was asking you how many devices are affected, so I will assume that the entire network, and that this issue is with the entire network, because after following up all the steps it is still not working. Then now let's move to the next step, and now the next step is this, where it is giving you the router status checking. Then again user says proceed. So again it is saying yes, I got it. Now again it is providing you another set of steps, and it is asking the question. After that, again troubleshooting agent provide you different kind of steps based on the user's request. Then again it goes to these number of steps, and then user say proceed, it did not help me. So now after that, it is saying that both the router and modem and device has not resolved the issue. Let me focus on your connection and verify the status. So it is now verifying the connection from its side. Then after that, it once everything is done, then it could not do anything, then it goes back to escalation agent. Escalation agent says that if you already connected your ISP but the issue persists, you might need to consider additional steps. So it's going to tell that, okay, these are the factory reset, right? And then after that, if the issue is still not resolved or is resolved, it is asking, it is telling the feedback agent, the handover happened to the feedback agent, and feedback agent is telling that it sounds like you are very frustrated, you have reached this point, here are the final suggestions. It is giving you final suggestion, and again it is finding that it is not working out. So then it is telling that, okay, you want me to connect you to the different agent, or again you want me to connect to the human agent. So all that conversation is happening. You see, how the feedback agent, escalation agent are working together, right? How the escalation agent again going back, and again feedback agent is asking the feedback, and then after that escalation agent is again coming in picture, and then again providing you a couple of steps, and finally everything is done. Then either the message is received, okay, and it is also giving you general contact information for the where to connect, what kind of your toll free numbers where you can connect, right? So this is how the beauty of AI agents working in a team, right? You can see how the whole communication is happening, right? And finally once the message limit is received, right, and now finally the whole communication is completed. So this is how the whole agentic architecture works, right? We have learned different concepts in the agents. We have learned how the agents communicate to each other, how they maintain their state, how they work together as a team inside the team, right? How easy it is to create these overall concept of agents together, and then how you can spin up a AI model, or call the AI model. You can switch these AI model, different models. For example, in this case, I'm using the OpenAI. Okay, so with this, let me take up some questions. What is the difference between semantic kernel, group chart versus AutoGen? What kind of use case first fits both of them separately? Okay, so semantic kernel is a framework like a LangChain, right? And semantic kernel is something like a LangChain. You can also include semantic kernel here if you are using a LangChain, right? AutoGen is a framework, open source framework, and uh, semantic kernel is a again a LangChain kind of framework, right? You can mix and match. You can use both of them together. Um, can we use semantic kernel for multi-agent orchestration? You can use semantic kernel for multi-agent orchestration, but generally in AutoGen we have these capability of orchestration already there in built into it, right? Uh, come to know from previous reactor session that for production ready agents, what is that? Come to know from previous reactor session that for production ready agents, SK70 kernel is better option and AutoGen is more for research. Could yes, that is correct. Semantic kernel. So AutoGen is not a production ready kind of environment. It is just for the research purpose and learning purpose. Because as you know that if you are using a production grade application, I would not recommend you to use AutoGen. There is a AI agent service in the AI Foundry. I would request you to use that. Right, it has everything inbuilt into it, right? So that is where what is this development UI? So development UI is here, just to simplify it, I am actually using a PyCharm professional edition, where I am running this whole code, and then the code output is coming in the here. Okay, so these are the aspect of AutoGen. Hope this session was very useful. If you have any further questions, please feel free to ping me on LinkedIn, or you can reach out to me. You have my details in the slide. Let me open it if you again want it. So yeah, here it is. So you can reach out to me if you need more help on that. I will be more than happy to help you on that. Okay. Any further question? Okay. Are they these decks and demo link shared? Um, I think I can do that. Not sure how do we do this in Reactor, but definitely you can reach out to me. I can provide you that. And what else? Any further question? Hope this session was helpful. Please provide your feedback.
Thank you so much for today's session. This was great. It looks like we don't have any more questions. So, yeah, thank you again for today's session, and we hope to see you again very soon.
Thank you, Alexia.
Thank you. Bye,
Have a
everyone.
nice day. Bye.